Comparison and logical operators. So last time we covered assignment operators, and we also covered Boolean and also variable types, integers, and float, and other sort of types that store numbers. So let's take a look at comparison and logical operators. So comparison operators evaluate two numbers, and that results in a Boolean value, which is true or false. And there are a lot of comparison operators, but these are the most common ones, if not pretty much all of them. You don't have to remember all of them, but we'll keep these running for the next few lessons, so you'll be able to see them more and more and be able to remember them. So, let's see here. Okay, so we have equals equals. Actually, I'll zoom. I won't be in speaker view because I want to be able to highlight these for people to see and modify them. Equals equals, not equals, greater than, less than, greater than or equal to, and less than or equal to. So comparison operators, obviously, they're very similar to the mathematical operators that people use, but there are some differences specific for coding languages. Not just Python, of course. So what is equals equals? Equals equals is essentially serves the same purpose as just one equals symbol in math. So for example, if we say x plus, for example, in regular math, right, we have x plus 7 equals 15. So then we solve for x or something like that, and 15 equals 15. Makes sense, right? But here's the issue. If you were here last week, or for anyone who wasn't here last week, the way that we assign data to a variable, which is something that stores data and you can access it later, right? So let's say Goofy is equivalent to 7. This is how you assign something in Python, right? We don't use an arrow or anything like that. We say equals. That's how we assign it. Just highlight that for everyone to see. So that's how we actually assign data or a number or whatever data type to a variable. But the issue is then how do we use equals, that sort of process, if we already have one? So let's just add another one, right? Goofy equals 7, right? And that will obviously, as a comparison operator, return if it's true or not. So 4 equals 4, right? So that's something that you need to almost reprogram in your mind for your coding brain, essentially, that 2 equals is equivalent to 1 equals in math. And that's how we actually check if something is equivalent. If you just use 1 equals, then you'll be reassigning it, and sometimes the code will error, because you can't just say 4 equals 4. 4 is not a variable, so it will be like, what are you doing? And then obviously we have a couple of them. Okay, let's move on. So what is this? This is called not equals. This exclamation mark, we use that as something called a not symbol, right? N-O-T, not. So not equals is pretty much what it means in terms of like English, which is it's the opposite of equals, and it's basically checking if two numbers or two things are not equal to each other. So the not symbol is mainly just used for not equals. But we can use it in front of something else. We can say, like, let's say we say, let's put a variable, rem. Let's say rem is equivalent to true. Or not equivalent to, equals true, right? So we assign rem to true. It's a Boolean variable. Now if we say print not rem, sorry about that. If we say print not rem, right, the code will print false. So that's how we can use not in other cases. And here once again are a couple of examples of that. And that's actually one important thing to discern is, we can, this is not that specific in terms of, even if there's a decimal point, it's still equivalent. Some coding languages might give you some trouble over that, but yeah, let's move on. So these are the exact same as what they mean in math, which is quite nice. Obviously greater than and less than. So if the number on the left is greater than the number on the right, it's true. If not, it's false. Same thing for the less than symbol. If the number on the left is less than the number on the right, it's true. If it's not, it's false, right? So obviously 7 is not less than 4, and -3 is less than 1 since it's a negative number. Okay. Now these ones, they serve the same purpose as the ones in math do, but they're written a bit differently. So the main issue with code actually is usually this is how we write something in math, right? Or at least is how I write it. I think this is generally how they do it in math, right? Which is if you want to put greater than, you put a greater symbol and then you put a dash underneath it to symbolize, greater than or equal to. But we can't do that. There's no key on our keyboard in order to be able to do something like that. And we can't underline it in a programming language. So we essentially just put them side by side, greater than or equal to, and less than or equal to, right? So it essentially follows it, greater than or equal to and less than or equal to. So that's how you write it. Just remember, it follows the way you say the words, greater than, equal to, less than, equal to. Right? So greater than equal, then less than equal. The symbol for greater than or less than always comes before equal. If you write it the other way, then that's not right, and I might error. So logical operators. Logical operators compare two Boolean expressions themselves, not integers or any sort of other data type. They compare Boolean, right? Boolean is true and false. So basically we can have variables store the true or false. So the main, the three are and, or, and not. Sorry, it's a bit of a play on words since there's and, but and, or, and not. So and basically means you combine both, right? So if you have, let's say, 3 variables, right? All of them have to be true in order to get true as a response. But if any one of those variables is false, then it will output false. So pretty much and means that everything has to be the same, otherwise it won't work. But that's only for true. If everything is false and one of them is true, it's still false. So that's the way and works. Is it everything that's combined with and has to be true in order for it to be true. But if any one of those variables or expressions is false, then everything becomes false on the other side. So if we take a look at this, true and true, both of these are true, and we tie them with an and. So both of them have to be true. So since both of them are true, we get true on the other side. Now, if we take a look, expressions, right? This serves the same role as this, right? 8 is greater than 7. That is true. So that's true on the left. And then, right, we have an and. -9 greater than or equal to 4. That is also true. So we have a true on the right. So we have 2 trues tied together with an and. And that is also true since all the expressions or things that are tied together with an and statement are true, we get true on the other side. Now, 8 is equivalent to 8. That is true, so that's fine. And we tie it together with an and expression. 7 is equivalent to 6. That's not true mathematically, so that returns false. So we're tying together a true and we're tying together a false. And remember, if any one of these things, or I guess data, is false, any one of these elements, then everything becomes false. So everything becomes false. It's a bit confusing, but if anyone has any questions, feel free to ask. So let's move on. Then we have the or symbol. Or is true if the Booleans or Boolean expression on at least one of the both sides is true and it's false otherwise. So or is more lenient, right? In the sense that if any one of them is true, then it's true, right? So for example, we have true or true. That is also true, right? Since both of them in this case, but if any one of them is true, then both of them are true, right? It turns out to be true. So 8 is equivalent to 8. That's true. And we have 7 is equivalent to 6. That's not true. However, this is not like AND, where all of the elements have to be true in order for it to be true. Since we have a true statement on this side, it is still true. However, if both of these were false, so let's say this is 9 is equivalent to 8, right? That's false. This is false. Then this would turn into false. So just keep that in mind. And yeah, so over here, same thing, right? -3 greater than 7, that's not true. 8 is not less than or equivalent to -4. So both of them are false, so it turns into false. Yeah, so this is another way to use not, right? Take a Boolean or a Boolean expression and reverses its truth value, right? So if we say not true, right? We say not true, that would be equal to false. That would be equivalent to false. This statement would be true, right? Since this becomes false with the not statement, it reverses its truth value, you could say. Its Boolean value, essentially. Yeah. And let's keep going. Yeah. So I will link this in the chat, since that may have been a bit of a confusing lesson, since technically it is a bit of a play on words. So I will link that below, and this will provide any answers to any sort of questions you may have, as well as, I think, a bit of practice. So let's keep going. We only have 5 more minutes, so I will just begin the other lesson, and I'll go quite slow since I may have zoomed through the comparison and logical operators of this. Strings. A string is an object that contains letters, numbers, and symbols. But a string is essentially a combination of characters, right? So car, I love to play basketball. And yes, there can be spaces here. Unlike variable names, you can have spaces in strings. And then obviously we can type in whatever we want, right? We can type in numbers, we can type in symbols, right? But it will work all the same. And the thing is, once it is entered into a string, right, a number or a symbol, right, it will be considered a character no matter what. A number may have an integer value, let's say 7, right? But when you take a look at it through the eyes of the code, it sees it as a character, nothing more. It doesn't see it as a number with a numerical value. So that's something to keep in mind. Now, string concatenation. We use the addition sign, like math, but instead of combining numbers, we're combining strings. So it essentially merges the two of them together, like boom, and then boom, and then boom, right? So there's no space in between them, essentially. So we have cat plus dog, that turns into cat dog, right? No space in between, it merges the two together. And we can also do that in print statement. We assign greeting to hello, earth to world. If we combine the two together, we get hello world, right? So you can do concatenation both in variable assignment and also printing it out so you can see it. Now, string indexing. This is something that's quite important and a unique property, right? In terms of having a data type that actually stores it in terms of like its initial state. But we'll cover what the other type stuff are later. So each character in a string, see character like A, B, C, D, has an index starting with 0. It does not start with 1. That's the main difference, actually, between when you count, you start from 1, 2, 3, 4, 5, 6, 7, 8. But in code, we start from 0. So we go 0, 1, 2, 3, 4, 5, 6, 7. So if we were to create a string that has, let's say, 8 characters, right? Then that means it has index 0 to 7, right? And if we count 0 to 7, right? 0, 1, 2, 3, 4, 5, 6, 7. It's 8 characters. But we start from 0. So you have to think -1 in terms of getting the last one, and getting the first one starts with 0. So that's something that's unique to code, right? Quotation marks are not included for indexing, right? So zeros and then 1. So we're taking the hello world. And yes, spaces are counted as indexes. So they are counted, they're not counted as characters necessarily, but they kind of are. So spaces, letters, numbers, symbols are all characters in a string. And the code will look at it as characters and nothing more than that. So another thing is string indexing is very important because we can access parts of the string, known as something called substring. So sub is a root in English. Not a root, I think it's a prefix. Yeah, prefix in English, which means to take a part of. So, for example, if we want to print the 4th character of this name, right? Let's take a look. Remember, we start at 0. So 0, 1, 2, 3, and 4. So N is the 4th one, so it outputs just that letter. Now let's say we have this sport string. You don't need to define the string name. You don't need to define your data type. It can be like this, and it will understand it. Or maybe in general, just define it like this. Python sometimes will be able to understand what you're saying with primitive data types. I'm not so sure with data types that are not primitive like string, but yeah. In general, defining them is usually better. For beginner coders, you don't need to define them. That's why Python is known as a kind of beginner language. It's very welcoming to beginners. But either way, let's move on. That was a bit of a tangent, sorry. So we take a football, right? What is the 0th index? This is the 0th index since we started 0, F. So we'll print out F. And we can also access using negative indexes, right? Which starts with -1 at the rightmost index and decreasing by 1, right? So pretty much we're going backwards now. Instead of going left to right, we're going right to left. So if we do, so pretty much we start from -1 and we just keep going backward and backward and backward, counting like that. And once again, spaces, numbers, all those same rules for strings, right? Where they're all considered as characters with their own index, respectively. So it's 2 p.m. That's all the time we have. If you have any questions, feel free to ask. I will continue going over this next class. And thank you so much, everyone. I'll see you guys next week.